Hello friends, in this video lesson, we are going to look at a couple of properties of square roots, which are going to be very helpful for you to deal with expressions which involve square roots. And we will see a couple of example problems which will help you understand. So let's get into that. So let's look at the first property. So what is the first property? If there is a number which is of this form, which can be expressed as square root of AB is A multiplied by B. So if it is square root of AB, that can be expanded into square root of A multiplied by square root of B. So as simple as it gets. So again, I repeat, if there is a number which can be expressed in this form, root of A multiplied by B, then it can be separated out in this form, which is square root of A multiplied by square root of B. Let us see an example. So we have square root of 8. Now 8 can be written as square root of 4 multiplied by square root of 2, which now is in this form, square root of AB, right? Which is 4 into 2. Now applying this property, we can rewrite this as square root of 4 multiplied by square root of 2. So now we know that square root of 4 is 2 because 2 square is 4. So your final answer is 2 multiplied by square root of 2. So essentially, we have simplified square root of 8 to 2 root 2. Let us look at the next property. If there is a number which is expressed of this form, which is A upon B, then it can also be written as square root of A upon square root of B. Let's look at another example. So let's say we have to find out square root of 0.64. Now 0.64 can be written as 64 upon 100, right? Because it's a decimal system. So 0.64 is equivalent to 64 upon 100. Now we are applying this property. We know that we can rewrite square root of 64 upon 100 to square root of 64 divided by square root of 100. Now square root of 64 is 8 and square root of 100 is 10. So your fraction reduces to 8 upon 10, which is 0.8. So essentially, square root of 0.64 is basically evaluated to 0.8. And so these two examples, I think you have understood how we can use these expressions to evaluate certain expressions which involve square roots. Let us see one more example. So let's say you are evaluating square root of 147 multiplied by square root of 243. So to solve this problem, if you remember our lesson on factorization, we need to apply factorization to both these numbers and see if they can be factorized and can we find pairs of numbers which can be moved out of the square root sign. So let us factorize. So if you observe 147, it is divisible by 7. So you have 147 as 21 into 7, right? And then 21 itself is 3 into 7. So final factors of 147 would be 3 into 7 into 7, which are all the prime factors. Similarly, 243, we can observe that it is divisible by 3. So I can rewrite it as 81 into 3, but 81 is 9 square. So I write it as 9 into 9 into 3. So let us use these factors in place of these numbers in our solution. So rewriting this expression like this, where we have 147 rewritten as 3 into 7 into 7 and 243 written as 9 into 9 into 3. So since we have a pair over here, which is 7 square and which is 9 square, so this will be split into 7 root 3 multiplied by 9 root 3. Why is the 7 moved out? Because you have two 7s under a square root, which is under root of 7 square, which will evaluate to 7. Similarly, under root of 9 square will evaluate to 9. And you remember the property we just studied. Each of these elements can be separated out. So I can separate out root 3 and separate out 7 square, right? So now further solving this, you can, all of these are in multiplication. So you are left with 9 into 7, 63, multiplied by root 3 into root 3. Now root 3 into root 3 is 3, which gives us 63 into 3. That is the final answer, which is 189. Let's look at this problem. It is a nested set of square roots where you have one square root under the other. So you have square root of 225, again added to square root of 154, again further added to whole under root of 108. So everything under square roots, right? So how do we approach this problem? So you start solving the farthest square root, which has no plus signs involved. Square root, you start with the most nested square root first. So look at 225. Do you know what is the root of 225? So 225 is equivalent to 15 square. Therefore, root of 225 will evaluate to 15. So now you will rewrite this expression as this whole thing plus 154 plus square root of 225 evaluates to 15. So we have 15. And now, similarly, in a step-by-step way, we are going to keep solving the innermost square root and go out. So 154 plus 115 will solve to 169. So again, 169 is 13 square. So this evaluates to 108 plus 13, which adds up to 121, right? So we get one square root of 121. Now 121 is 11 square, which means square root of 121 gives us 11. So we have 10 plus root of 25 plus 11, which adds up to 36. Square root of 36 is 6, which adds up to 16, and square root of 16 is 4. So this entire expression adds up to 4. So this is quite a simple problem to solve, although it looks scary here. But the thing is, you must look at the piece of this puzzle lies here. You should solve this and then rest all of it will unfold. So hope you enjoyed this session. Thank you.